Got that? You have the significance level. You have to calculate the test statistic. So you have the sample mean minus the population mean. The population mean comes from the claim itself. That's where the population proportion came from. That's where the population mean comes from, the claim. All right. Then S, that is the sample standard deviation divided by the square root of n. They do all that and they get this as the test statistic. So make sure that you can do this in your calculator and get that. You always want to make sure that you're operating your calculator correctly, because the calculators are definitely your friend in this class, which I know you know by now. All right. So once you have that test statistic, then we have to use or calculate that test statistic and use it to find the p-value or the critical value from table A3. Okay. So we have the test statistic. Since we have this test statistic now of negative 0.486, we're going to use that in our table. Alright, so we need to find this critical value now. We have the test statistic. I may have said we had to use it in the table, but we don't use this actual number in the table. We use a number from the table, and I'll show you how we can use what's in the table to figure out whether we reject and fail to reject. We can also find the p-value if we want to. So if you use the critical value method, then here's what you have to do. Here's the test statistic, negative 0.486. We need to find the critical value from this table here. Alright, make sure you're not looking at the chi distribution, it's the critical t-value. Now, we said we were left-tailed, and so if we were left-tailed and our significance level in this particular problem, let me go back up to the beginning, is 0.05. Okay, so left-tailed is in one tail, right? Yes, because left-tailed is just one tail, like this. Right-tailed is one tail, and then two-tailed is just what it sounds like, two tails. So we're in one tail, and our significance level is 0.05. All right. So we have to use this column here. Now, our degrees of freedom come from the number of data items minus 1. So the number of data items in this set was 11. 11 minus 1 is 10. So 10 is my degrees of freedom, and I'm over here in this column right here, 0.05. So match those two up, and you get a critical value, a critical t-value of 1.812. Alright. Once we have that critical value, you may say, well, why is it negative? You didn't say anything about negative. Because it's left-tailed. If the average of the middle is 1.00, and it's left-tailed, left-tailed means it will be on the left, so the critical value is negative. So it's negative 1.812. Alright, here's the significance level we used, which really doesn't matter in here. Our critical value is right here. Our test statistic is to the right of that. So because that number's close to 0, or closer to 0 than this number. Since our test statistic does not fall in this critical region here, then we fail to reject the null hypothesis. Let's say that our test statistic would have been negative 2, then it would fall in the critical region and we would reject the null hypothesis. But our test statistic was negative 0.486, so we failed to reject the null hypothesis. Now the reason why I'm not using the p-value method with t-test is because the p-value method with the t-test or the next test that we do called the chi distribution or chi-square test, I don't use the p-value method because you have to have the technology. So if you have the TI 8384 or any of the statistics programs that will do that type of stuff, then that's fine, you can use it. But the majority of the time you're not going to have those, or you don't know how to use them, so that's why I used the critical value method with with the standard deviation unknown for the mean. Alright. So this goes through how to find the range of values. I think there are a few on your homework, and I explained how to do that in the video for the test review. But let's see, this is how to find a range of values for the p-value using the table. So if you don't have the technology, you can estimate a range of values that it will be within. Let's just look at one of these real quick. In a left-tailed test, the sample size is n equals 12, and the test statistic is t equals negative 2.007. Alright. Alright, so we have to use the table and the test statistic to help estimate where the actual p-value would be, if we just want to do that. Probably not the best thing to do, but it's still a good thing to do if you don't have the technology. So let's go to the table real quick. So here's the table. We want to look at, depending on the information we have, alright, so n equals 12, that means our degrees of freedom is equal to 11. And since this is left-tailed, our test statistic is going to be always negative, but we want to use the positive. So in all these we're going to use, you're going to have to use the positive because of your test statistic. Because if you look here, all these critical values are positive. So whenever you're using the test statistic to estimate the p-value from the table, you have to use the positive. Okay. The degrees of freedom is going to be 11, right? 12 minus 1. And then 2.007. So what we have to do, we know it's left-tailed, so it's one-tailed. Alright. We know that the test statistic is negative 2.007. So in one tail, so we're using these up here to estimate. And then we need to see where would our test statistic lie down here. So we have to use the positive, like I said, but our degrees of freedom is 11, and our test statistic, so we're going to have to use these numbers here. Our test statistic of 2.007 will lie between these two right here. So if you go to the top, it's for 10, for 11, because, yeah, so 2.00 lies between these two here. So that means your p-value is going to be between 0.025 and 0.05. You just don't know what it is. Okay? Let me do another one of those, because first I wasn't very clear on how to do that. Alright, so if it's right-tailed and sample size is still 12, so we're going to use the same degrees of freedom, 11. The test statistic, 1.222. So go back to the table, and here's 11 right here, so degrees of 1.222 is going to be less than all of these. Alright, so that's going to tell us that, you see how these get progressively larger, that our p-value is going to be greater than 0.10. We don't know what it is, we just know it's going to be greater than 0.10. Alright, so that's how you can estimate. Would I estimate all the time? Definitely not. But if you're asked to, that's how you do it. I usually don't do the confidence interval method, but your book does go through how to use the confidence interval method as well. Now, if you do know the population standard deviation, which doesn't happen a lot, then yay, it's back to a z distribution. So we use this z formula. All right, and again, the p-value can be provided by technology. It says, or the standard normal distribution. So very good, very good. So here's an example of the cell phone radiation. Find the z as your test statistic. So if we find that, it says this refers to a left-tailed test. So you just follow that table if you want to find the p-value. Left-tailed, so the area is to the left of the test statistic. Remember, if you want to find area to the left, that's what our table actually shows because it's cumulative from left to right. So this is what you would get in table A in your z-score chart. It says since the p-value is large, we fail to reject the null and reach the same conclusion as before. So you remember the significance level is 0.05, so that is much larger. So it's smaller than 0.005, we reject, but since it's larger than 0.05, we fail to reject. All right, and that's it for this.